You don't remember the formula that you guys used to calculate. Okay, but now do you know what is momentum?
Yes, yes.
Okay, this is where we're gonna start. We'll start with momentum, right? So momentum, we're referring to the product of the object's mass and velocity, you understand?
Yes,
So momentum is denoted by P, and the formula that we'll use to calculate momentum is the mass times the velocity. Are you with me on that?
yes,
Right. So on this formula, the P, this is your momentum, and this is the mass of the object, and this will be the velocity. Okay,
yes,
right. So now, one thing I need you to understand, this is very important. Né? You see momentum, we refer to momentum as a vector. So momentum, it's a vector. Do you still remember what is a vector?
yes, sir.
Right. So this means that it has magnitude and direction. So the direction of the momentum is in the same as the direction of the object velocity. Are you with me on that?
Yes,
So this tells you that if the mass is constant, the momentum is directly proportional to the velocity. Okay, look at the formula. You can say that if the mass of this object is constant, the mass is not changing, we can say that the momentum is directly proportional to what? To the velocity, okay?
yes.
Okay, let's just do maybe a quick example. This will just be a nice example. So on this example, let's say that I have a truck that has the mass of 4,580 kg. So this truck
Yes,
is going south with the velocity of 30 meters per second. It's going to the south, and they want you to calculate the momentum of the truck. Remember, momentum is just P, mass times the velocity. So I'm just going to substitute what I'm given, which is the mass of 4,580. This is multiplied by the velocity. Then you punch this on the calculator. What do you get? What is your answer?
let me do that now. 4, 5, 8, 50, 137,400 kg
137,400
milliseconds south.
meters per second. Remember,
Yes,
we said that this track is moving to what? This track is going south. So the direction of the momentum will be south. Why? Because we said the direction of the momentum is in the same direction as the object's velocity. Okay?
yes,
Right. So now that you understand momentum, as we're going to work on past papers, you need to know how the change in momentum works. Okay? The change in momentum. Right. So on the change in momentum, when we say the change in momentum, let's say that an object is moving, right? So when a moving object it collide with another object. So we have two objects that they collide. So the velocity of the object will change, and this will cause what we call the change in momentum of the both objects. So if two objects collide, uh, there will be what? The change of momentum, because the velocity of the object will change. Are you with me on that?
yes, sir.
And the formula that we use is the change in momentum. It's equals to the P final, you're going to minus your P initial, which is just the change in is the mass times the change in velocity. The mass times the change in velocity. So the best way to write this formula is to say M inside the bracket, you're going to take your V final, you minus your V initial. That's how you calculate the change in momentum. Okay?
Yes.
So while we are still on the change in momentum, I just want to quickly give you an example, okay? So
Yes.
now, let's say I have a wall like this.
Yes.
Okay, this is my wall. Right, so we're going to uh, have a tennis that will move in that direction, and let's say it moves in that direction with the velocity of 5 meters per second, right?
Yes.
So now what happens is that the tennis or whatever the ball, it will hit the wall and come back with the same velocity in an opposite direction, okay?
Yes.
The velocity will be the same. So now I want us to talk about uh, this type of example that we have here. Just give me a second, okay? Let's look at this. So what I'm going to do is that, let's say this ball, it has the mass. So this will be an example, because the reason I'm doing this example, there's something that I need to explain here. Let's say the mass of this is 2 kg, right? And then we are saying that it's traveling east with a velocity of 5 meters per second, and then it rebounds at the same speed, and they want you to determine the change in momentum of the ball. Okay, so what I'm going to do when I determine the change of momentum of the ball, I'll first take east as positive. So I'm going to take the east as positive because this is traveling to east. Are you with me on that?
Yes.
So the change in momentum, we said the formula for change in momentum is the mass into V final minus V initial. And then now, if I do the substitution, the mass is 2, and this will give me. So now, let's quickly just do that. Right. So on the data, I said that the mass of the ball is 2 kg, and then we set is as positive. So this will be my V initial, and this will be my V final. So my V initial is the one that will be positive 5 meters per second, and then my V final, it will be negative 5 meters per second. Why? Because the V final is pointing in an opposite direction. So I'm not sure if you get this, né?
Yes, I get it, sir.
Right. So now when we substitute the V final, it's negative 5. Then we subtract what? We're going to subtract the V initial, which is positive 5, right? And then you're just going to punch that on the calculator, and you can say this is minus 5, which is 2 into minus 10, and that will give us negative 20. So the answer is negative 20. So now I'm going to conclude and say the change in P is equals to 20. Can you see that I'm not including the negative?
Yes.
So the change in momentum will be 20 kg meters per second. Now, since it's negative and we set east as positive, so this tells you that the change in momentum is going west. Are you with me on that?
Yes, sir.
So you know what I'm going to do? The reason I chose this example is because I need to explain something. In momentum, the direction is important, okay? So the direction is important. Okay, so
Yeah.
now uh, the direction is important when dealing with momentum. So when the object rebounds, the change in momentum is never zero. The change in momentum when the object rebounds, it is not equal to zero. It's never zero, okay? Are you happy about that?
Yes, sir.
Okay, 100%. We're just gonna work on a few examples, then we'll keep and go to the past paper. Don't worry. Okay, so now what I need you to understand is that uh, let's say that I have a ball, the very same ball. You see the one that we have here. Let's say that I want to give you two type of example. Remember that at first the ball hit the hole and then it rebounds back, né? And
Yes.
then when it rebounds back, let's say this time the very same ball is going to travel to that direction with the velocity of 5 meters per second. But now the interesting part about this example is that when it travels to the wall, it's going to hit the wall. I'm going to try and draw the ball with a different marker. So this is this is the ball. It's going to hit the hole and then it stays on the hole. I'm not sure if you understand this.
I do, sir.
Right. So this time is not bouncing back. It stays in the wall. Tell me, when it stays in the wall, are we going to get the same momentum when it rebounds, or are we going to get a greater momentum, or are we going to get a smaller momentum? What do you think?
We get a smaller one.
A smaller one, because it's going to stick, and then when it sticks, this tells you that the final velocity is what? It's zero. If this is the v initial, the v final is equals to zero. And when you calculate the change in momentum, it will be the mass into the v final minus the v initial, which is mass of 2, 0 minus, right, 5, right? Because we're going to say is as positive. So when you look at this, we're going to get negative what? Negative 10. Even
Yeah.
when it sticks at the wall, the change in momentum is still negative. So this tells you that your momentum is going west. Do you understand
Yes.
how this works?
Yes, sir.
Okay, right. Uh, so this type of question you must expect it in multiple choice, because they might ask you which one will have a greater momentum when the ball hit the hole and it rebounds, and then when the ball hit and sticks to the hole, which one will have a greater momentum? Then they'll say option A, option B. You understand what I'm trying to say, né?
Yes, sir.
Okay, so to conclude this, in collision, the change of the momentum of an object that rebounds, it will always be greater than the object which remains stationary after the collision, okay?
Yes.
Should I write this down?
Yes.
Okay, let me write it down for you. In collision, we are saying that the change in momentum, so the change in momentum of an object that rebounds is always greater than what? It's always greater than an object which will remain the same. No, which remains stationary, not the same, which remains stationary after collision. After collision. Okay, so
Okay.
now that you understand this concept, I think we can dive into impulse. Né?
Yes.
Right. So when we talk about an impulse, impulse is the product of the net force and the contact time. So the formula for impulse, we're going to use F net multiplied by delta T. This is equals to the change in P. Okay. So now the F net is going to be your net force. Delta T will be the collision time. So delta T, that's your collision time. So this is your collision time. F net, this will be your net force. And the net force will be in newtons. And we know that this is your change in momentum. Okay, 100%. So now, okay, so now it can be, if you look at this equation, you can see that an object impulse is the same as its change in momentum. So now, impulse, what is this telling you about impulse? I'm going to say impulse is going to be directly proportional to what? To the magnitude of the net force applied on that object and the contact time of the force. Okay, so impulse is a vector. If you still remember, we said momentum, momentum is a vector. So impulse also, impulse is a vector. Okay, impulse is also a vector. Okay, so it has the same direction as the net force acting on that object.
Yes.
Okay, uh, I want us to look at one, maybe one example, and then we're gonna use maybe the remaining time to dive into past papers. I don't know. What do you think?
Yes, no problem. Good idea.
Okay. So now, before we go into past papers, there's this formula that we're going to use multiple times. Né? The formula, it goes like this. We call this the conservation of linear momentum.
Mm-hmm.
So this is the conservation of linear momentum. Uh, this one, the total linear momentum in an isolated system, it remains constant. So when we talk about an isolated system, we are referring to a system with no external forces, such as friction and applied force. Okay. So when dealing with conservation of linear momentum, please remember that there are four general types of collision or events. We have four types. Okay. The first one
Yeah.
in an exam, they might give you a collision where object moves separately after the collision. Ne? Are you with me, John? Did you get that?
Yes, sir.
The first one, I'm not going to write this down because we're going to waste time if we write them down. The first one
Okay.
is when the object they move separately after the collision. The second one is the collision where object will stick together after the collision. Okay.
Yes.
Number three is the collision where objects are dropped vertically in onto a moving object. And the last one will be explosions.
Okay.
Okay.
Got it.
Right. So we can work through uh, some of the examples so that you can understand how this works. Né?
Yes.
Okay. Because if I just want you to tell me what you think we should do. If I go through all those type of examples, just know that we won't manage to get to a past paper, or maybe you want us to dive into past papers. Look at how they ask this type of questions in a past paper. What do you need?
Yes. The second choice.
Past papers, ne?
Yeah, to see
Okay,
how they question it and then we could answer it as is.
okay, just give me a second to open one, okay?
No problem.
Okay, let's look at this question. Let's look at this question. What are they saying on the statement? Can you please read the statement for me?
Ball A with a mass of 0.5 kgs moving with a velocity of 3 milliseconds to the right collides with a stationary ball B mass equals to 0.25 kgs. The stationary ball is connected to a light inextensibly string. After a collision, ball B swings upwards to a maximum height as indicated in the diagram below. Ignore the effects of air resistance.
Okay, so ball A is going to collide with what? With ball B, and ball B is stationary, right?
Yes.
With the V initial of 0. Okay, so now I'm just going to try to answer this question step by step. Remember, we just talked about what we call the momentum. Remember, we just defined the momentum, even though I did not write the definition down for you. But this time I'm just going to put the definition down, okay?
Yes.
Right. The first one, it says define the term momentum. And we said momentum is the product of the product of an object mass and what? And its velocity, right? So calculate the momentum that ball A had before collision. So look at this. If you want to calculate the momentum, remember we said the formula. If we can go back to our notes, we talked about
Equals,
the formula for momentum. So momentum is the product of the mass times the velocity. So P will be equals to the mass times the velocity. You just have to sub in the mass of ball A. That's why they put this in bold, because you don't have to substitute for ball B, but for ball A. The mass of ball
yes.
A is 0.5 and the velocity of that is 3. So what do you get when you punch that? What is your momentum?
1.5.
1.5 kg meters per second. Okay, so another thing that you need to know is that remember, where is ball A going? In that direction. So ball A is going to
Yes.
the right. So when you calculate
Right.
momentum, you're gonna say you take right as positive. That's why the velocity that we substitute that velocity as positive. So since the answer is positive, our momentum is moving in the direction of the velocity. You happy about
Yeah.
that?
Yes, sir.
Right. They say after collision, ball A continues to move to the right with a reduced velocity of 1.6 meters per second. So this is the velocity after collision for VA. So this will be the final velocity, the velocity after collision. And now they want us to state the conservation of linear momentum, which is what I just told you now. I said the total linear momentum of an isolated system remains constant, meaning it's conserved, okay?
Yes.
The total isolated system, we say, remains constant. Then you get that 2 mark. Okay, this is 4 mark, and then they say they want you to calculate the magnitude of the velocity that ball A or ball B had immediately after the collision. Okay, so I'm going to teach you about this. Remember, we said that we talked about when they want you to find the velocity that ball B had after the collision. We said the sum of momentum before
Yes.
is going to be equal to what? Is going to be equal to the sum of,
Is the triangle P equals M triangle V?
is it what?
The M to VF minus VI.
Are you saying minus?
No, no, I'm looking at the other sum because it was negative. They made it negative.
Oh, okay, no, it's equal. The sum before, it's equal to the sum of the momentum after, né?
Yes.
So meaning that when I say the sum of before, let's start with the two objects. So I'm going to take the momentum, which is the mass of A. We're going to multiply that by the V initial of what? Because before it's V initial. V initial of A. You add the 2 of the momentum of the second object, which is B, uh, times the V initial of that B. This is for what? B for before. And then we equated this with the mass of that A. This time we multiply by the V final of that A. And then we add the mass of B times the V final of that B. And this is for after. A for after, okay? So when you look at this, the mass of A is given as 0.5 and the V initial is 3 for A. So this will be the mass, which is 0.5. Then this is multiplied by the V initial, that is 3. So remember, I'm still considering my right as positive, okay?
Yes.
Then I'm going to add this with the mass of B. Look at this. The mass of B from the diagram is given as 0.25. So this will be 0.25. 0.25. This should be multiplied by the V initial. Remember, before the collision, B was stationary. So the initial velocity of B is 0. So this will be multiplied by 0. Then we equate this to the mass. After the collision, this is 2. And then they said that uh, after the collision, ball A has a final velocity of 1.6. So this will be the final velocity of A, which is 1.6, plus the mass of that, which is 0.25. And we are looking for what? We are looking for the velocity of ball B after the collision. So I'm just going to leave this as the velocity of B, the V final B. Do you understand the substitution?
Yes, sir.
Okay, so let's just try and work this thing out. It's like saying 0.5 times 3. It's like saying half times 3, which is 1.5. So this is 1.5. I'm going to add this. Okay, it's just going to be 1.5 plus 0, né? Which is
Yes.
1.5. Then I'm going to equate this to, can you please help me with this one? What is the answer on your calculator? What is half of 1.6? 8, 0.8 plus 0.8 is 1.6, right?
Yeah. Yes.
So this will be 0.8, and then we add 0.25, the velocity of that B. So I'm going to move this one this side to be negative. So this will be 1.5 minus 0.8. It's equal to 0.25 VFB. And then what do you get when you subtract the 2? What
The
is,
1.5 minus the 0.8.
yes, What's your answer?
0.7.
0.7. Let's equate this to 0.25 VFB. Then I'm going to divide this side by 0.25, divide the other side by 0.25. Therefore, my VFB is equal to, what is your answer when you divide by your answer by 0.25?
0.8.
0.8.
2.8.
You got?
2.8.
Okay, so this will be 2.8 meters per second. And that's your answer. Do you understand how this works?
5 minutes.
Hmm?
Yes, sir.
The next question says that they want you to determine the maximum height. Okay, the maximum height uh, reached by ball B after the collision. Okay, so you know what I'm going to do? I just want to give you a quick exam tip. Ne?
Yes.
When you work with this one, I'm just going to try and give you a quick exam tip. So now, you see, when we talk about the conservation of mechanical energy, this has to do with the conservation of mechanical energy. Né?
Yes.
I'm going to give you a short way, but I don't want you to apply this in an exam. I just want you to understand how this works, okay? So, in the conservation of mechanical energy, so the conservation of, I'm just going to call this ME, mechanical energy. So at top, just know that at top, you're going to have your kinetic energy to be 0. And then your potential energy to be what? Uh, Wait, kinetic energy, let's say this is EK. So the kinetic energy will be EK. So this is EK, it's equal to 0. And then this one will be max. Okay, I'm going to explain what I mean by that. And then at bottom, at the ground, at ground. So on the ground, you're going to have your EK, let's say your EP. Potential is the one that is 0. And then your EK, it's max. So let me explain. Let's answer this question. So determine the maximum height reached by ball B after collision. So this has to do with what we call the conservation of linear momentum. So the ME, to answer this, we're going to say the ME bottom is equal to the ME at top. Okay,
Yes.
mechanical energy is the sum of kinetic and potential energy. Do you know that?
Yes.
So we're going to take the kinetic energy, which is 1 over 2m v squared. You add that with mg h. Then equate this to the one on top, which is 1 over 2m v squared plus mgh. And there's a mark for that formula. So what I'm trying to say is that at top, your EK is 0. This one is B for bottom, this one is for top. So at top, your EK, which is this one, you're going to get 0. Your kinetic energy will be 0. And then at the ground, your EP is the one that is 0. At the ground, this is the bottom. At the ground, your potential energy, it will be 0. So this tells you that uh, the work, okay, let me not talk about the work. So this tells you that EP is equals to EK. In conclusion, EP, the potential energy is equals to what? Or let me just write it like this. EK instead, let me write it like this and say, this tells you that EK is equals to EP. Because look at this. This is your EK and this is your EP. They are equal. Right. When you do the substitution, I'm going to say this is, I'm just going to substitute to answer this 4.5, okay?
Okay.
So this will be 1 over 2, the mass of ball B, because we are doing for ball B. The mass of ball B is 0.25. So this will be 0.25. Then the velocity of ball B after collision. We calculated the velocity after collision as 2.8. So this will be multiplied by 2.8. Right. So now we know that this is 0. Why? Because the height at the bottom, the height is 0. So just to save space and time, I know that, let me indicate this here. I know that when I do the substitution for this one, but in an exam, I expect you to substitute this and say the mass is 0.25 times the gravity of 9.8 and the height at bottom, which is this part here. This is the bottom, at bottom, so we are trying to work between these two. So at bottom, the height here is 0. And then I'm just going to say, since the height is 0, this is multiplied by 0, which makes everything to be 0. So that's why we substitute 0 there. Do you understand why I'm saying that your EK, at the ground, your EP is 0. Your potential energy is 0.
Yes.
Okay, then I'm going to equate this. Let's equate this guy to, we know that this is 0, but I'm going to substitute it on the other side. But in an exam, I need you to substitute everything. I'm going to substitute here. So this is 1 over 2, the mass of 0.25. So at top, the velocity of ball B at top is going to be 0, because it's going to reach what? Maximum height. It's going to stop and reach the maximum height where the V final will be 0. And now we know that the V initial, the V at this one is going to move this point here with the V of what? 1.6. Please don't say it's 0. Okay? So now what I'm going to do is that I know that this will be at top, it reached 0, which makes everything to be 0. That's why we are saying that the EK at top is 0.
Yes.
Okay. Now when I do the substitution, I'm just going to substitute this part. The mass is 0.25 and then 9.8, and we are looking for H, the maximum height. So can you please assist me with the calculator? What is this equals to?
1 over 2, 0.25. 0.35.
You got 0.35. Oh, we
Yes.
forgot to square this 2.8. What do you get when you square the 2.8?
Do it now.
Oh,
0.98.
okay. So this side is 0.98. It's equal to, can you say 0.25 times 9.8? What is your answer?
0.25 times 9.8. No squared.
You got,
No.
did you say 0.25 multiplied
Yeah.
by 9.8?
Yes.
And what's your
Which is
answer?
2.45.
2.45.
Yes.
Then now the next thing is to divide this by 2.45. Divide that by 2.45. Therefore, your H, whatever that you get, is going to be the height that we are looking for.
2.45. 0.4.
Your answer is?
0.4.
Okay. So the height is going to be 0.4. If that's what you get, 0.98 divided by 2.45. 0.4, right?
Yes.
Meter. Okay. I just want to confirm this quick. 0.98 divided by 2.45. 0.4, 100%. Thank you very much.
Yes.
Okay.
Also, could we end off at 7:40?
Yes, yes, yes.
No problem.
Yes, we are ending now because this is it. This is the last question. We won't be able to start another question.
Yeah,
So
yeah.
this is where we're going to stop. So I'll try. I don't think you need this notes. Now you don't need this notes, right?
Now I've got it.
Yeah, okay. Now thank you very much for joining in.
Mm.
I
Yeah,
think
thank
I'm gonna
you.
see you. Okay, I'll tell you when we're scheduling again, okay?
No problem.
Sharp, sharp. Have a great evening.
Thank you. You too. Bye, sir.
Sharp, sharp.